When your technology has a destination and your eye is on consistent quality, you have the right formula for a successful business. Just ask Ralph Hutchison. Hutchison is the founder of Scientific Materials Corporation in Bozeman, Montana. Since 1989, the firm has been growing and manufacturing superior crystals for optical components that are used in many applications: medical procedures, high-power lasers, remote sensing, telecommunications, optical memories, high-speed data processing, and laser machining, to name a few. In Hutchison's business, knowing the destination is critical.
Well, the thing you have to realize is that materials lead device development by 7 years. And so everything that's coming now on the device field were jobs that we worked on 7 years ago.
In the mid-1980s, Hutchison learned something from NASA that set Scientific Materials on its way. Superior quality crystals were going to be in demand, a destination for his technology.
In 1987, Frank Valerio, then NASA Flight Director at Center at Langley, gave a talk at CLEO, and he was talking about the needs of NASA as far as lasers in space. And I sat back in the audience and said, well, I can do that.
So he wrote a proposal for NASA's Small Business Innovation Research, or SBIR program, explaining how he planned to do it. From then on, Scientific Materials has cultivated a close working relationship with NASA.
It was really a marriage of sorts to make it, to kind of make some of these things happen. But it was what NASA wanted to do, it was what we wanted to do.
Over the years, the company has been able to supply NASA with a variety of crystal samples for research projects in many areas, such as measuring ozone and water vapor levels, optics studies, power generation, and taking wind shear measurements. One of their crystals is actually part of a laser instrument now flying aboard the Mars Global Surveyor. Initially, the samples for an experiment were very expensive, but Scientific Materials was committed to bringing down costs. It became a selling point in their proposals, finding methods to produce a range of samples for a particular experiment and at a reasonable price for the researcher. They've done just that.
We're doing this by making the product itself cheaper because it's easier to make, it's more consistent, and that type of application. So, for example, things that used to cost $100,000 can now be built for $10,000.
One of the reasons for being able to reduce costs has been the relationship the company has developed by working with faculty and students from a nearby university.
Working with the university was critical to our future. And the thing that we found in doing this is that the university needed us on an equal footing basis because we could do things that they couldn't do.
Although the company may have brought down the prices on their products, they are committed to maintaining the utmost levels of quality. From the raw materials to the finished products, attention to detail goes into every step.
Everybody in this place is, very quality oriented to making sure that they do their job in the manner that achieves the end product.
Growth in the military, energy systems, and the medical field has meant an even greater demand for Scientific Materials products. Communication with their customers has been key to targeting their products to the right markets. Scientific Materials has doubled in size every 3 years, and their largest commercial product is ND-YAG, which has its genesis in the first SBIR work they ever did. When asked why the firm is so successful at transferring their technology, Hutchison has a simple answer.
Because that's what we're supposed to do. You don't work on something that's not useful. You don't work on something that there's not a market for. And you don't work on things that don't satisfy your customers' needs.
With a quality product in hand and knowing where it should go, Ralph Hutchison has made Scientific Materials into a very successful small business.